What's up guys, my name is Preston Palmer with Student Engineering. In this video we're going over the cross product, and if you find it helpful, please subscribe. So the cross product is a way of multiplying two vectors where the result is a vector itself, and that looks like if you're multiplying vector A by vector B. So that's right, A cross B, well then that would equal a vector C. So the magnitude of vector C is going to be at its greatest when vector B and vector A are at 90 degrees from each other. And it's going to be at the smallest, it's going to be at 0 in fact, if they are both parallel to each other. So the bigger the angle up to 90 degrees, the bigger the magnitude of vector C. And so that can be written out as the magnitude of C equals the magnitude of A times by the magnitude of B times by the sine of the angle between them. So we know that if theta is 90 degrees, then sine is going to equal 1, which will be A times by B. And so we can represent that geometrically if we have vector C right here and vector A and vector B. Well, if the angle between them is 90 degrees, then the magnitude of C is the area formed by this square right here. And if it's some other angle, it's still going to be the area of the parallelogram formed by vector A and vector B. Like that. So it's going to be the magnitude of vector C is the area of the parallelogram formed by vector A and vector B. If vector A and vector B are not going in the x and y directions, again, vector C is going to be 90 degrees or exactly perpendicular to the plane created by vector A and vector B. Because the cross product is multiplying two vectors, there are laws of operations that you have to follow. So in regular multiplication, it doesn't matter the order in which you're multiplying the numbers, but in the cross product it does matter. So A cross B does not equal B cross A, but rather A cross B is equal to negative B cross A. Or in other words, if A cross B is equal to C, then B cross A is equal to negative C. So this property can be shown visually by using what's called the right hand rule, where if you stick your right hand out, we'll say that my arm is going in the direction of the second vector in our cross product, and we'll say that the first vector is going 90 degrees from it. So in this case, vector A would be in the direction of my fingers, and vector B would be going in the direction of my arm. And vector C would be coming off 90 degrees from it, or in the direction of my thumb. So what we do is we say that you curl A towards B. So my fingers are going to curl from A towards B, and my thumb is going to be pointing up. Well, if we say B cross A, well then to curl in the direction of A to B, we have to curl, or from B towards A, we have to curl in the opposite direction, and my thumb ends up pointing down. So another couple of properties that we need to know about is the associative law, which follows pretty closely what we know about regular multiplication. And that is if a vector or a scalar A is multiplied by the cross product of A and B, well then that is going to equal A times by the vector A cross B which also equals A, the vector A cross A times by the vector B. And so you can see that A, the scalar value, only multiplies by one or the other vector, and it doesn't matter which. And another property we need to know about is the distributive addition property, where if we have vector A cross B plus vector D, well then that equals A cross B plus A cross D. So to be honest guys, you're probably not going to use those properties of cross product very much, but what you are going to use is how to find the cross product, and you'll do that by using this formula. And you're probably wondering where that comes from. Well, it comes from a 3x3 determinant written like this. A cross B equals, the top row is the directions of I, J, and K, and the second two rows are the components of A and B. So A sub X, A sub Y, and A sub Z, and B sub X, B sub Y, and B sub Z. And so this picture shows you how you can solve this determinant, where this is how you find the I component or the I element, this is how you find the J element, and this is how you find the K element. And so if you need to, pause the video, you can look over this and maybe even write it down in your notes. Alright, so in this video we're not going to go over how to actually apply the cross product to solve a problem, but we are going to go over how to find the cross product of two vectors. And so say we're given the vectors A and B, and we want to find the cross product. What I usually like to do to start off with is to write out the determinant, and that helps me. Instead of using the formula we had written out, I can remember better of just how to solve the determinant. So A cross B is equal to I, J, and K, and then the X component is 2, and then 3 and 4, and you see we don't have an I component, so it's only in the Y and Z directions, so we're going to put a 0 here, and then a -1 because there's a -1 there, and then the 5. And we're going to multiply that out, remember, we're going to cross out these two rows that have the I in it, and it's going to be 3 times by 5 minus 4 times by -1. And that's in the I direction. Now for the J direction, we're going to cross out the rows with the J in it, and we're going to do 2 times by 5 minus 4 times by 0. And remember that it's negative because that's just how you solve a determinant. So 2 times by 5 minus 4 times by 0, J, plus, cross out these two rows, 2 times by -1 minus 3 times by 0. And that's the K component. So what you end up getting is A cross B is equal to 3 times by 5 minus 4 times by a -1, so that's 15 plus 4, so you have 19I minus 10 minus 0, so minus 10J, and then 2 times by -1, so -2 minus 0 is minus 2K. Alright guys, so that's how you solve the cross product of two vectors. And if you found this video helpful, please hit that like button. Let me know if you have questions or suggestions down in the comments below. and subscribe if you want more videos like this.